Morning, legends. Hope you're having a lovely break. Time to get cracking. I'm going to go through some requests. This is the first video today, which goes through a set from one of our legends. There they are there. They're from the 2016 TSSM and MAVs. Thank you. You're going to support other people in their quest to being legends. So simply, don't be a twit. I'm going to show the question. You should have a go at it by pausing the video if you haven't done it yet. And then if you need, watch my solutions. I don't know how fancy I'm going to get with these, but the more questions you throw at me, the more videos I will do. There's another set that I might do tonight from another legend who sent them, but I'm going in order of the questions I received. Here we go. First question. A core question, late core, which means it's finance. And as we know, this was our, we did well, but it's a constant area of trouble. And I read the question. Andrew takes a personal loan of $5,000 for a year, which charges interest every month. King, remember, very important, the recurrence relation that models his loan is given below. Now, just because it's very good practice, think about what this means. Okay, he starts with 5,000 to get the next value, increase the previous value by 1.0125 and then take away 450. So we can see what's happening here. He gets charged interest on the amount owing at a rate of, there it is, I'll talk about that more in a second. And then he makes a repayment, a regular repayment of 450 each week. There's a lot of ways to do this, but the quickest, easiest way is to realize that increasing something by 0.0125 per month can easily be related to a yearly rate. So to increase by 0.0125, 0.0125, in terms of a percent, that's the same as 101.25. Therefore, it's an increase of 1.25% per month. Don't forget the king, per month. Now this asks per annum. So therefore, it's 1.25 by 12% per annum. And if you do that correctly, you can type on your CAS, bang, 15. Really good question. Thank you. I'm just moving on. I'm trying to make these quick so you can pause and whatnot if you're not sure. Delete. Next. Question 7 matrices. Here it is. Check it out. Pause if you need to pause. And do it yourself. Let matrix P equal 2, 3, 4, 7. The inverse of matrix K times P, where K is scalar, is. Okay. Good question. So the K is scalar. Don't be scared. So it just means that there's a number K out the front which multiplies each of the elements of matrix P. So I could rewrite that, if you like, as 2K, 3K, 4K, 7K. That means exactly the same thing. So now the inverse of this matrix, you know what you have to do, don't you? You swap these ones over and change the signs of these ones, but also there's a determinant at the front. So it equals 1 over the determinant of this matrix. You swap these over and you change the sign of these ones. Now I'm getting very close already, aren't I? I can see now that this one is close, but I've got to consider this determinant, and that's going to change things. Now, what would I do? Well, I can work out the determinant. I was thinking I was about to go to CAS, But I really think this one's quicker if you just nut it out. So now the determinant equals AD minus BC. A times D is 14k squared minus B times C is 12k squared. Now that equals 2k squared. Now, this is cool. So now I've got the determinant. It's 1 over 2k squared outside of 7k minus 3k minus 4k, 2k. Now, the k's are going to simplify. See this? The k's are going to simplify. That k there will cancel out k's here. So I've got 1 over 2k. 1 over 2k, 7, 3, blah, blah. That's interesting. Is that A? I've got to check. Is that the right answer? I got a different answer. I'm going to try this another way. Go to my CAS. Oh, I was working out something else there. Control N. You know the trick. Now I'm going to put this in as K's and work out the inverse. So 2k, use times just to make sure your calculator knows what's going on. 3 times k, 4 times k, and 7 times k. And I'm just going to throw a little power of -1, which is the inverse. Boom. Aha. So I got those numbers. That's cool. If you can see what's going on here, this has divided all the whole numbers by 2, and there's still a k on the bottom. So the best answer for this is divide the numbers by 2. Or why is there a 4 there? That shouldn't be there. 1 over 2k, 7. No, the k's haven't cancelled there. That's got the k's in the wrong spot. I think this, well, the first one, 1 over 2k, 7, 3 minus 4, 2. Yep. It's A. Is that, I hope that's the answer they gave. I'm not sure it is. There could be a mistake in this question. I'm calling it A. And I'd solved it 2 ways and got the same answer with the CAS and with by hand working. I would think with these go straight to CAS. I think the answer specified by TSSM is actually D. It's not D, folks. I'm calling it A. That took way too long. I'm sorry. I'm going to go more quickly than that. Please hit me up if you think I made a mistake, because as you know, that happens. That happens. Next question was networks question 8. Here is the question I prepared earlier. I remember this question. Another student asked me about this question. It's another dodgy question. The length of the shortest path from A to G. It's a shortest path problem. So this is like a reading time. You can usually do these in your head. Of course, we've got to avoid the big numbers. The 5's a bit big too. And you look, so I've got to take this path. So to get to E, what's the quickest way to get to E? 4, 6, 7, 2, 3. 2, 3 is definitely quickest. So it's actually 6. The length of the shorter path from A to G. 2, 3 is 5, 1 is 6. I'm hoping that's right. I think the answer they gave was A. No way. It's another dodgy question. So this fine student who sent through these questions, I think, was just confused as to why their answer was wrong when I think it was right. Okay, last one for TSSM 2017. Do 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 do. What a lovely day. Can't wait to go for a pedal. Oh, wow. It's a doozy because you've got a precedence table and you've got asked for a critical path. This can only mean one thing, which is rare, and that is we've got to actually draw the activity network and then do our forward back scan to get our critical path. So, whew, this is a doozy. It's more for an exam 2, to be honest, or a very cruel last question of the module. So here I go. This takes, as you know, it's hard to draw networks. A and B have no immediate predecessors. Let's kick it off. A, 2. B, 3. Now, C has an immediate predecessor, and that is A. C has immediate predecessor, that is A. Now, C is of 4 days duration. Let's keep it going. D has immediate predecessors of A and B, and it goes for 5. So I'm seeing dummy here. D goes for 5, A and B. That's a dummy. I can put in A0 or D0 or whatever, or nothing. E has a C and D as predecessors. So look, I'm getting another dummy here. I'm going to put E off the back of C, and it goes for 8. But D also is an immediate predecessor, so I've got another dummy. There's probably another way to do this. F, straight off D. Yeah, I can do that. And it goes for 3. G, straight off F. G, straight off F. H, straight off G. Okay. G, straight off F. I'm just heading because I can see what's going to happen here. G, straight off F for 2. H, straight off G for 3. And I'm going to extend E. There we go. So E has no immediate predecessor, but it's got to be done. Otherwise, the job won't be finished. So this point here represents my finish point where all jobs are completed. Okay. Now, this is a multi-choice, and it's taking up a lot of time. That's why it's a bit unusual. So now to get the critical path, I have to forward back scan. So here I go doing the boxes. Big boxes, or highlighter pen is better. Should have done that. Just go whack, whack, whack highlighters to create your box areas. You never marked on these boxes. They're just a method. Here I go. Pick another color, brown. So scanning, forward scan, 0, 2. Now I'm thinking that goes down there, so think about it. 2 there, but 3 this way. Biggest on the way out, of course. 3 and 5 is 8. Now this way, 2 and 4 is 6. But I've got to put an 8 there because it's biggest on the way out. 8 and 3 is 11. 11 and 2 is 13. 13 and 3 is 16 that way. 8 and 8 is 16 that way. Oh, that's interesting. Now back scan. Earliest completion time 16. 13. These ones are all going to be spot on. Now careful this way. 16, 8. Aha. This way, 5 and 8 is 3. 3, going back, we take the biggest, remember? 8 take 4 is 4. 8 take 4 is 4. So that way we're going to get some slack time there. And 3 take 3 is 0, but that way, yeah. All right. Critical path time. It's taken a long time. Get your highlighter out. 3, 3. 8, critical also. Yep. Both of these paths are critical because 16 is the minimum completion time. Earliest start time for E is 8 going this way because we've got that dummy from D. So, what is the answer? The critical path identified here is, well, we've got 2. Interesting. They've identified, well, definitely it starts with B. So use our brain here. Definitely it starts with B, so we kill that. Now, from B, it takes to D, so we kill that. Now we've got BD, E, BD, dummy, E, H, BD, H, E. Jeez. Here's the confusion again from that learned student. B, D, and there's a dummy, E. That's a critical path, B, D, E on its own. Now the H, the other one, B, D, E, H, B, D, E, H. Well, that's some sort of weird clash of critical paths. H has an immediate predecessor of G, which has a predecessor of F. So this is, I'm calling it, it's another little dodgy question. The most correct, but it's not quite, is C as they've put. But the paths don't, it's not a true critical path, that, because E, 8, H, you can't start till 13. It's actually not a critical path. Weird question, but a good question for practice. So thanks to that student. I've just got to move on. I don't want these to go forever. I do wish the holidays would go forever. Okay, next question. Question 19, Core Mav 2016. We're into the Mavs. Expect them to be a bit harder. Expect them to not have mistakes. Early TSSM 2016, that's early days. So they're getting better, these trial exams. Mav, though, are usually spot on. I'm not expecting mistakes. Antonia invests 15,000. Okay, she's offered a rate of 6.5% per annum compounding quarterly, and I'm getting my, crown, bang, quarterly. Don't forget. Antonia asked for the same interest to be compounded weekly. The increase in effective rate. Okay, so just quickly, effective rate is the rate you'd get if it was one-off bang interest rate across the year. But of course, compounding quarterly and weekly, it changes the effective rate because you're getting interest on interest. So you're expecting it to be slightly higher than 6.5. How much higher? So this is CAS. EFF bracket, comma, blah, blah. Rate, number, compounds per annum. So to work out the effective rate for the first one, we're going to put in 6.5. Hey, how many times does this happen per year? Quarterly. And then we do the same with the second time frame, 6.5, 52. And then the difference should be our answer. So let's get busy. Okay. So we're going to put in, you just type EFF, boom, it jumps. The first one at 6.5%, comma, just, was it quarterly? Come on, brain. Quarterly, 6.66. So that would be this, rather than 4 increases, it'll be the same as 1 increase of 6.66.016, not rounding yet. Then I do the same for the second compounding period, 6.5, but it's weekly, 52. Bang, 6.7. So now the difference, or the increase, that minus that, enter, boom. It's a 0.0514. Now, I didn't do any rounding because I was in the middle of the question. So you can do that using your CAS. So the difference in the effective rates, if it's compounded weekly, it's going to be an increase of 0.05. Why? Well, really try and understand that, because you're getting more interest calculated. So your interest on interest gets more time to grow with the 52 calculations rather than the 4 quarterlies. Great question. Next, we're getting there. Whoop. Doom. Doom. Get out and about. Enjoy the sun. We're down to matrices question 8 from Tia Mav. Here it is. I love these. They're little logic puzzles. It's about this order and, matrices, and there's some rules. P, Q, R, S are matrices such that the calculation P times Q times R plus S is defined. Now, straight away, I've got a fact here. For this to be defined, you're adding the result of P times Q times R to S. That means, straight away, P times Q times R has the same order or size as S. Dodgy color. They must have the same size, otherwise you couldn't add that result to this result, because you can only add matrices of the same order or size. Okay, P and R are square non-zero matrices for which P plus R is not defined. So there's more clues to this lovely puzzle. Order P does not equal order R, and they're both square. Okay, this is cool. If S is a 5 by 2, oh, there it is. So S is a 5 by 2, which means the order of PQR must be a 5 by 2. Now, P has got to be square, R has got to be square. The answer, remember when you multiply two matrices, the rows and columns tell you the size of the answer. So P has got to be a 5 by 5. How do I know that? Because of what has to result. R has got to be a 2 by 2. How do I know that? Because the outsides give us the resulting order. And when I multiply whatever PQ is by R, I've got to end up with a 2 on the outside. And the same, whatever I multiply PQ by, I've got to end up with a 5 on the outside. So the only way for this to work is, so my colors need to be better here. That's not a change. That's P. That's R. Now, this must be a 5 because these have to match. Otherwise, you can't multiply them. Now, this has to be a 2 because when I get a 5 by 2, when I multiply these numbers have to match. So there it is. It's tricky, and you might want to replay that and think again, but there's only 2 facts I used really. When you're adding matrices, they've got to be the same order. It gave us the order of S, so we know the result of this has to be a 5 by 2, so we can add this. And the fact that these are 2 square matrices and we have to end up with a 5 by 2, basically it gives you the Q in the middle. So the answer to that one is It's a 5 by 2. D. Matrices question 8. D. Is this another one why you picked this? Maybe their answer is different. Maybe that's why you asked me. But please, in the comments to this post, just say, "Hey, you made a mistake." But no, I didn't say bloody. I'm very confident. I'm going to get rid of that, and we're doing the last question. Come on. Clear annotations. Last question from Mav, and it's a double whammy. Stop, pause, do it, try it, whatever. Activity network shown below, the number of activities that could individually be delayed by 3 hours without affecting the overall time. Okay, so we've got Slack. This is delaying activities without completing project time. We're talking about Slack here. So we're looking for things that have a Slack, or what's another name for it? I can't remember. Hashtag holidays. We're looking for things that have a 3 or more hour Slack time. So we've just got a forward back scan. Zero. Get to there only one way. 5. Get to there 2 ways. This way is 8. This way, 5 and 7 is 12. 12 and 4 is 16. 16 goes there. 2 ways to get to there. 16, yep. 12, that's 18. This way, 19. So 19 goes here. The biggest. 16 and 3 is 19. Yep. 19 and 8 gives me 27. 16 and 5 is 21. So 27 goes there. Back scan. Now we're putting in the smallest possible. 19 goes there. No other way. 2 ways to get there. There's 16. Yep. That's the smallest, because 27 minus 15. So 16 goes there. There's 2 ways to go there. 12. Yep. 12. And now we've got 5. 17. 12 minus 7. 5. 0. Okay. Critical path. I don't even know if we're going to need it, but just do it. Whoops. 12 and 6 is 18, so this is the critical path. Got to make that bigger. It's really important. And then the 27 comes through there. All right. Now, didn't really need to do that, but it doesn't matter. Practice. The number of activities that could be individually delayed, okay, by 3 hours without affecting the overall completion time. So now we're thinking about, oh, look at B here. I can start B at 5. Only takes me 3. So I could be finished B at 8, but I've still got another 8. B could be delayed definitely by 3 hours. E, it takes 6. I got to 19 to finish it, but that means I've only got 1 hour slack for E. Could start it like 12, 18. It's got to be finished by 19. No. The only other option here, not on the critical path, is G. G, I could start at 16. 16 and 5 is 21, which gives me 6 hours. Boom. So there are 2 activities there that you can delay. Because it says individually, you don't have to consider them both together, which makes it a bit easier. Okay, the last one. Because of staffing issue, activity F cannot be started until E is completed. The earliest completion time for E, that's interesting. If we can't do F until E is completed, then that takes this path way out of it, which means I'm not going to change the whole network because that's sort of what you could do. It means that now 18 through this way becomes the new earliest finish time for E, which means you can't start F until 18 has passed. Which means 18 and 3 is 21, which changes that to 21. Oh, come on, pen. Which changes, so just recapping here. I can't start F until E is finished. The earliest finish time for E is 18, because we go this way, which means the earliest start time for F is 18. 18 and 3 is 21. So it changes this to 21. Now, if this changes to 21, 21 plus 8 is 29. 18 and 5. Yep. So 29 will be the new overall completion time, which means the project is delayed by 2 hours. 2 hours. That's the last question that was offered up today. I'm going to pause that there. I'll be answering the next set that was sent through to me maybe tonight. Cheers. Good luck.